Hey, welcome back. We're actually at our final lesson in Unit 1. Unit 1 is very brief, it's only 3 lessons. It's going to be called Fractional Exponents. So Unit 1-3, Fractional Exponents. And we're going to jump to Chapter 7 in your textbook, Chapter 7, Lesson 5. Alright, again, just the expectations. I'll throw these up here at the beginning of the year just to get you used to them. Remember, please limit your distractions as much as you can. Write down some stuff in your notebook as needed. Make sure you do the practice problems. That'll be important for you. And just consider giving us a question. Write down one well-considered question. We'd like you to make sure you have that for us the next time we see each other. Okay. Again, if you see these real quickly, watch only, put into your notebook as notes, and practice those problems when you see those icons up here in the upper right. We're still in Standard 2.0. 2.0 is a pretty big standard. It's going to be with us pretty much till the end of the school year. Today we're going to learn to evaluate and simplify expressions containing fractional exponents. Let's pause for a second there. We're going to learn to evaluate and simplify expressions that contain fractional exponents. Fractional exponents. What does that mean? Well, if we go over here, let me grab my pen here real quick, and let's take a look. A fractional exponent looks something like this. If I'll get it to right, there we go. Fractional exponents. Let's say we have some base, let's just call it x, and this would be like x squared, right? Well, that's an integer exponent. So what if we had x to the 1/2? Well, now this is a fractional exponent. All right, so that's where we're going today, and we're going to show you just how simple this can be. All right, let's take a look. So here's our vocabulary. Remember that this is called the index. We talked about this previously. The small number to the left of the radical symbol that tells which root to take. For example, this 3 here in the index represents a cubic root. And of course, a 4 there would be a 4th root, and so on. So, since 8 equals 2 times 2 times 2, the cube root of 8 is simply 2. So there's a hint for you. The index equals the root. We'll come back to that a little bit later. This index here means find the root of that number. Okay, so keep that in mind. Alright, just watch this for a second. This is a watch only. If we have 16 to the 1/2 power, 16 to the 1/2 power. Now remember what I said, the index equals the root. So here's what I want you to do. The bottom of the exponential fraction tells what root. So this right here says we're looking for the square root of this number, and then the numerator of our fraction is going to give us something else. This becomes the exponent. So we're looking for the square root of 16, and now we're going to apply an exponent to the answer here, raised to the 1st power. Well, what is the square root of 16? Well, the principal square root of 16 we know is 4, so this is simply 4 to the 1st power, which is just, of course, 4. Okay? I know this is an awkward thing to look at. You're probably wondering, well, why don't they just use this radical sign? Well, when you get further along in your math studies, you're going to be using exponents more. And this exponent here just simply means take the square root of 16. So how about this here? 8 to the 1/3 power. 8 to the 1/3 power. So again, the bottom number here is 3. So we're looking for the cube root of 8 raised to the what power? What should go up there in the exponent? Well, how about a 1 again? And we know from earlier that the cube root of 8 is indeed 2. So 2 to the 1st power is 2. How about 27 to the 1/3? So which one's our root? 1 or 3? Well, it looks like 3 is. So 3 is our root, so we're looking for the cube root of 27 raised to the what power? The 1st power, and we know that to be 3. So pretty straightforward there. Notice that the denominator determines the root, which is the index, right? Alright, now consider, can a fractional exponent have a numerator that is not 1? Well, this being a math class, you know that that's going to be true, right? They're going to go ahead and give us a numerator other than a 1. So just watch this and we'll see how this works. Again, let's focus on the bottom. The cube root here of 8 happens to be, I think you already know the answer to that. The first step is going to remain exactly the same, the cube root of 8. But now what's our exponent up there? This exponent is not going to be a 1, it's now going to be a 2. So now what is the cube root of 8? Well, the cube root of 8, of course, is 2. And then what is 2 to the 2nd power? In this case, 4. Okay, is our final solution there. 8 to the 2/3 is indeed 4. So we go back. Cube root of 8. We'll satisfy that first, which gives us the answer of 2, and now apply the exponent. Remember, order of operations, we take care of what's inside the parentheses first, then exponents. All right, now an easy way to remember the difference between a root and an exponent. Roots, like a tree. The top of the tree, we have the tree and the canopy. The bottom are the roots. A math colleague of mine, way back in college, all those decades ago, actually, she taught me this, and I've never forgotten it. The roots of a fractional exponent, just like a tree, the roots are at the bottom. So roots are at the bottom of a tree, just as in a rational expression. So thank you, Adrian. All right, and one more time. 81 to the 3/4. 81 to the 3/4. What do you think? So where are the roots? Are the roots on the top or the bottom? Well, the roots, of course, are on the bottom. So we're going to go the 4th root. Remember that the root and the index are the same. So it's the 4th root of 81 raised to the what exponent? How about the 3rd? So the 4th root of 81 is 3. Remember, 3 times 3 is 9, and 3 times 3 is 9. That gives us 4 3's to work with. So there we got it. 3 to the 3rd power is indeed 27. 3 to the 3rd power is 27. Okay, let's see. This guy up here, of course, remember you've got your guy up here with the chalk. Why don't you try these on your own? Let's give this one a try. 16 to the 1/4. Look at that mess. 144 to the 1/2 minus 27 to the 1/3. That looks kind of tricky. How about this one? 81 to the 3/2, or the 3/2. Is that going to change anything? No, it's not going to change anything. Still the square root of 81 raised to the what power? How about the 64 to the 7/6 power? Oh, interesting. Okay, and number 5 here is going to be an expression for us to evaluate. And I tell you what, I'm going to leave these for you to try, and we will look at them the next time we see each other in class, hopefully tomorrow. Let's go ahead and take a look at those. You can pause if you'd like, write those down, and give those a try on your own. All right? And that's it for Unit 1-3. Again, if you'd like more instruction, go ahead and go to MA8CA 7-5. That's at thinkcentral.com. Type that in. And then in this case, you got 3 videos to look at, but they're all pretty brief, probably 2 to 4 minutes each, the most. And make sure you reflect on what you just learned and write down any particular question you may have. All right? All right then. We'll talk to you soon.